those words? They were indicating Beethoven would roll over in his grave if he heard rock and roll. Well, in the next few minutes, we're going to discuss the enormous waste in shielding gas that occurs in MIG welding, some of the reasons for that waste, and a way to fix it. We'll also introduce you to Daniel Bernoulli and show you why he'd be rolling over in his grave because of the lack of understanding we have, the basic reasons for that loss. Just how much waste does a shop have in MIG shielding gas? Well, the Fabricator magazine published an article in the June 2000 issue entitled Shielding Gas Consumption Efficiency. It summarized the findings of a company specializing in eliminating shielding gas waste. Their experience indicated the average fabricator uses 18 to 30 cubic feet of shielding gas per pound of wire consumed. That is 2.5 to 5 times the amount needed. In an article published in the January 2003 issue of Trailer Bodybuilders magazine entitled How to Save 20% on Welding Costs, a Proxair engineer quoted his experience indicating fabricators typically use 30 cubic feet of shielding gas per pound of wire, or from 3 to 5 times the amount of shielding gas they could use. Looking at this MIG system, the shielding gas cylinder is chained to the wall and the feeder is on a work cart. A 15-foot shielding gas delivery hose is connected between the regulator flow meter on the cylinder to the solenoid connection on the wire feeder. The regulator reduces the cylinder pressure to an output level that can be as high as 80 psi. Regulators for argon-based gases range from 25 to 50 psi in output pressure. However, when welding, it typically takes less than 2 to 4 psi to flow the shielding gas through the feeder and welding torch passages. We put a pressure gauge in the gas hose near the feeder. We can see that in this instance the pressure required to deliver the shielding gas measured at 3.5 psi. But when we stop welding, the pressure raises to the output pressure of the regulator, 25 psi in this instance. We'll repeat that. It quickly, as you'll note, goes back to 3.5 psi when we're welding, rises rapidly to 25 psi, and that excess gas is now stored in the gas delivery hose. In addition to the gas waste, we also get a very high gas surge. I'll put the torch near the microphone so you can hear it. This gas surge has been measured at levels up to 200 CFH, 8 times that required to produce quality welds. Let's define how much gas is stored in the hose and what causes the flow surge at the weld start. Daniel Bernoulli was born in 1700. Is credited with developing the theory and understanding of how gases behave under various pressures, flows, and temperatures. Bernoulli's equations form the basis of understanding how airplanes fly and numerous other fluid flow phenomena. However, we're not designing airplanes, and we can simplify what we need to much less complex and intuitive equations. For our needs, the equation becomes much simpler. The ratio of the volume of gas in the gas delivery hose, measured at standard temperature and pressure, when we're welding versus when we're stopped, is equal to the ratio of the absolute hose pressure when welding versus when stopped. If you're using CO2 shielding gas in cylinders, even though the gas is less expensive than argon-based gases, the waste situation is even worse. Regulators for CO2 service often use an outlet pressure of 80 psi to prevent ice particles from forming. The excess gas is equal to 5.2 times the volume of the hose. This 5-fold excess in volume produces a very high gas surge at the weld start and any time the torch switch is energized. As mentioned, even when just inching the wire to cut off the end or positioning the wire in the weld joint. In addition to the high surge flow at the weld start causing gas waste, the high flow rate also causes air to be pulled into the gas stream and into the arc. This entrained air leads to poor weld starts. At normal flow rates, the gas shielding column is steady and smooth at the air shielding gas interface. At high flow rates, this area becomes turbulent and the gases exchange in this area. This can lead to excess spatter at the weld start and porosity in the deposit. It takes a short time for the gas stream to stabilize even after the high flow returns to normal. One way to reduce the excess gas waste is to reduce the volume stored in the gas hose. By using an 1/8 inch ID hose instead of the more normal 1/4 inch ID hose, reduces the cross-sectional area by 4 times. Therefore, only 25% of the excess stored gas is present to be expelled. The small pressure drop in the WA Technology Gas Saver hose further reduces the wasted gas by an additional 5 to 8% depending on the hose length. This provides an overall reduction of over 80% compared to a standard 1/4 inch hose. We can further reduce gas waste and eliminate the problem of poor starts by incorporating a flow restriction orifice at the feeder end of the hose. We have built such a flow restrictor into the Gas Saver system hose fitting at the wire feeder end. By using this patented Gas Saver system, you can save significant shielding gas cost. You will usually pay for the system in weeks depending on your usage. You'll eliminate excess shielding gas surge at the weld start and the resulting excess spatter or weld porosity problems. You'll change gas cylinders less frequently, eliminating that waste of time. The Gas Saver system hose is very rugged and durable. It's fiber reinforced and has a very heavy wall. You can even step on the hose without closing up the ID. To learn more about the products we have at WA Technology that can help you reduce your shielding gas waste, visit us at www.netwelding.com. That's netwelding.com. Thank you.